All right, so with overdamping, there's a few observations we need to make. So first of all, let's recall that our two roots, R1 and R2, were given by the following equation. We had negative gamma plus or minus the square root of gamma squared minus 4 times m times k, right? All divided by 2m. Cool. So this equals, if we simplify a little bit more, it's going to be negative gamma plus or minus gamma. If we take 1 out of the root, this is what we end up with inside the root. We have 1 minus 4 times m times k, all divided by gamma squared. Okay. Oh, sorry. Let me go ahead and zoom back out. Get us back to where we need to be, right about there. Okay. And so this will then equal, and this is the most important equation out of the bunch. It'll be negative gamma all over 2m, okay, multiplied by 1 plus or minus the square root of 1 minus, forgot to mention this was all divided by 2m up above. My apologies. Now that makes a lot more sense. So 1 minus 4 m times k, all divided by gamma squared. Okay? So this final equation then allows us to make a very important observation. Okay? And that observation is gamma squared is greater than 4 times m times k. This refers to the overdamping situation, right? So this must imply that 1, it must be bigger than, if you divide gamma squared to both sides, 1 remains on the left-hand side, and on the right-hand side we have 4 times m times k, all divided by gamma squared. Okay? And so using this, we can see that the fraction under the square root is less than 1. So then if the quantity under the square root is less than 1, this means that the square root of this quantity is also going to be less than 1. So to put it very clearly, this quantity, as a result of overdamping, 1 minus 4mk divided by gamma squared, is going to be less than 1. That's all I was saying with that statement. Okay. So of course you're asking, why is this important? Well, the quantity in the parenthesis is now 1 plus or minus a number that is less than 1. So this means that the quantity in the parentheses is guaranteed to be positive, and so the two roots in this case are guaranteed to be negative. Therefore, the displacement of the time, t, is going to give us the following equation. It's going to give us u of t, which is going to equal c1 times e to the r1 times t plus c2 times e to the r2 times t. Okay? And this will approach 0 as t goes to infinity. So once again, the damper does what it's supposed to do. So this case will occur more specifically when gamma squared is larger than 4 times mk. So I believe that looks familiar. That's referring to this back up here, right? So this implies that gamma is greater than 2 times the square root of m times k. Okay, so this implies that gamma will be bigger than gamma CR. Okay, and again, when this occurs, this is called overdamping. All right, and so in the next session, I will discuss underdamping.